Hello and welcome to another installment of HansonMath.com videos. Today's video regards how to find the determinant of a square matrix. Before we do that, we're going to do a quick warm-up. From my previous lesson, we learned how to find the inverse of a matrix. Here I have matrix A, which is a 2 by 2, and we learned that for a 2 by 2 only, there is a nice little formula that you can use to find the inverse, and it works like the following. If you refer to this element in row 1, column 1 as A, row 1, column 2 as B, row 2, column 1 as C, and row 2, column 2 as D, you can use the formula. So we have A inverse equals 1 over A times D is this kind of negative sloping diagonal product. 2 times 2 is 4, minus BC, which is the upward sloping diagonal product. Negative 3 times 1 is a negative 3. And now we multiply that times this new 2 by 2 matrix, which is just rearranged. Things got moved around, and on this diagonal, the signs changed. So now D goes in the upper left, so that's 2. B is now just the opposite sign, so instead of negative 3, it's positive 3. C is the opposite sign, so instead of negative 1, it's, instead of positive 1, it's negative 1. And A is moved down to the bottom right, so the 2 goes here. Okay? Now we have to simplify a little bit. So we have 1 over 4 minus a negative 3 is 4 plus 3, which is 7, times 2, 3, negative 1, 2. So now this 1/7 is a scalar. It distributes to all 4 elements. So you have 1/7 times 2 is 2/7. 1/7 times 3 is 3/7. 1/7 times negative 1 is negative 1/7, and 1/7 times 2 is 2/7. So everything here really is fractions of the size sevenths, and the 7 we're going to find out is called the determinant of the matrix. It's just the denominator part of the fraction. Just the AD minus BC part is called the determinant. One way to remember this is that it's the negative sloping product minus the positive sloping product. So again, if we just do that part, the 2 times 2 is 4, minus the 1 times negative 3 is negative 3, you get 7. So the determinant of matrix A above is 7. That's how you calculate the determinant of a 2 by 2 matrix. Next, we'll practice with a couple more examples. If you'd like to hit pause and give it a try on your own based on the above, that's totally fine. I'm going to work through here. The determinant of matrix B is, again, I'm just going to think about it as the product of the downward diagonal sloping entries. 2 times 2 is 4, minus the product of the upward sloping entries. 4 times 1 is 4. So the determinant of this matrix is actually 0. So on the next one, we're still working with the 2 by 2. We have the determinant of matrix C equals, it's A times D, which again is the downward sloping diagonal. 0 times 4 is 0. Subtract the product of the upward sloping diagonal. 2 times 3/2 is just 3. So the determinant here, 0 minus 3 is negative 3. Now, you can use a graphing utility on your calculator. We work with TI-84s primarily, and you'll find it under second matrix you go over to math, and the first number one application should be DET, which is the determinant. So, for example, if you were to take the one that we just solved here and enter it into matrix A and do determinant of A, you will find that you get -3. So what's nice about the graphing utility on the calculator is not only will it find the determinant of 2x2s, it can do 3x3s and 4x4s and monsters that are really, truly tedious and easy to make a mistake by hand. And finally, while we're on this topic here on this page, kind of like a special case, if you will, if you have a 1x1 matrix that just holds one element, such as, let me just pick the number 8. If our matrix is a 1x1 and only contains one number, such as 8, its determinant is just that number. So the determinant of this matrix is just 8, in case you have any practice problems like that. Next, we're going to move on to a subject called minors and cofactors of the matrix. In order for us to determine by hand the determinant of a square matrix of order 3x3, we're going to have to find what's called the cofactors, and first we find the minors. Now, there's other applications. These cofactors can also be used to find the inverse of a 3x3 matrix. Others on YouTube, such as Patrick JMT, already have pretty clear videos on that, so you can look those up. But for the sake of this video, we're going to work on finding the minors of this 3x3, followed by the cofactors. So to save a little bit of time, I set up my array of minors. However many elements are in your matrix, the minors will have the same amount. So there's one calculation for every element of the matrix. Essentially, you're finding smaller determinants for each spot. So what I'm saying is the following. To find the minor from row 1, column 1, this tells you what not to look at or what to omit. So I'm going to scratch out row 1, and then I'm going to scratch out column 1. So you're left essentially with the 2x2, and we're going to find the determinant of that. So if we go this way, -1 times 1 is -1, minus 0 times 2 is 0, which is -1. Now, if I erase that, we'll start working on the next entry, which is the minor of row 1, column 2. So we're going to not look at row 1 or cross it out, and then we're going to not look at column 2, and then we're going to find the determinant of the remaining 4. So we've got 3 times 1 is 3, minus 4 times 2 is 8. 3 minus 8 is -5. Okay. Next, to move on to the third element in row 1, we are going to scratch out row 1 and not look at column 3 and find the determinant of these guys. So we've got 3 times 0 is 0, minus 4 times -1 is -4. So our minor there is +4. Okay, I'm going to switch colors, and now we're going to work on minors of row 2. So here we have the minor of row 2, column 1. So we're going to scratch out row 2, scratch out column 1, and find the determinant of what's left. 2 times 1 is 2, minus 0 times 1 is 0. So the minor there is 2. Okay, next, we're going to do the minor of row 2, column 2. So row 2 is gone, column 2 is gone. Let's do it. 0 times 1 is 0, minus 4 times 1 is 4. 0 minus 4 is -4. And the last thing we need to do here in row 2 is work on the minor from row 2, column 3. So in row 2, column 3, we're not going to look at row 2, we're not going to look at column 3, and we're going to find the determinant of what remains, which would be 0 times 0 is 0, minus 4 times 2 is 8. 0 take away 8 is -8. Okay, finally, we're going to move on to the final row, row 3. This is a little bit of a tedious process. And let's change colors again. And we'll work on the minor from row 3, column 1. We're going to scratch out row 3, scratch out column 1, find the determinant. 2 times 2 is 4, minus -1 times 1 is -1, and that sums up to +5. Okay, move on to the next position. We will have the minor from not looking at row 3 and crossing out column 2. So we have 0 times 2 is 0, minus 3 times 1 is 3. That gives us a -3. And last but not least, we have one more element here. So we're going to not consider row 3 or column 3, like so. 0 times -1 is 0, minus 3 times 2 is 6. So we get a -6. Now, this is convenient for me to do on my pad because I actually spotted one error here. Something wrong with, actually, no, we're good. So this is actually very conducive to being done on a dry erase board or a whiteboard. Sometimes students also will take 2 pencils and they'll cover up a row and a column. Some students even kind of scratch out likely with pencil, but then there's a lot of erasing. So you'll have to come up with your own creative way of how you can not look at the given row and column so that you can compute these minors. Next, you'll notice that we're still working with the same matrix A. I still left the minors we just found on the screen, but now I've wrote down all these elements in terms of the letter C, which these are called the cofactors. Again, the cofactors are going to be of the utmost importance of finding the determinant next, and you can also use this to find the inverse of a 3 by 3. So the good thing is all the hard work has been done. The cofactors actually use the same numbers, like the same literal numbers as we just found in the majors, but there's some sign changes. So how it works is the following. Starting in the upper left with the cofactor of row 1, column 1, that keeps the sign that it originally had. The next one is the opposite sign, and then this one is you keep the same sign. So it's keep, change, keep. Then it just keeps alternating. Change, keep, change, keep, change, keep. So now we are taking the answers that we had for the minors and we're just applying the sign changes. So we're going to keep the same value that we had in minor 1, 1. So this remains -1. But this guy here is the opposite sign. So the -5 becomes +5. This one stays the same. So we're going to stick with 4. This one here is a sign change. So instead of 2, we've got -2. This one here stays the same. So we're going to keep -4. And then here we have a sign change. So instead of -8, we have +8. And in row 3, we have keep, change, keep. So we're going to have 5. This is a change to +3. And this is a keep to -6. So it's pretty much just you're applying some sign changes. I did give a chart on my note sheet, and it's quite simple. You just start with positive or keep up in the upper left, and it just alternates as you go all the way through your values. Okay, these are called the cofactors. Now we're going to segue this into applying these to find the determinant of this very matrix. So without further ado, we're finally going to find the determinant of the same 3 by 3 matrix that we've been working on. In the prior example, we found the minors of this matrix A, and we found the cofactors of this matrix A. Now we're going to use the cofactors of this matrix A to finally find the determinant. So how you do that is as follows. It's your choice. You may pick whatever row you want to work with, row 1, row 2, or row 3. For this example, I'm just going to choose to pick row 1. And what that means then is I have to also use row 1 of the cofactors to go with it. It's kind of a matching thing. So we are going to call this element A11, like the answer to row 1, column 1, the answer to row 2, column 2, and the answer to row 1. Oh, my mistake. I meant to say row 1, column 2, and the answer to row 1, column 3. So to find the determinant of matrix A, what you do is the following. You take this element here, which is called A11, and you multiply by its matching cofactor, which is C11. Plus, now you take the next element in that row, which is A12, times C12, and then you finally add the last element in the row, A13, times its matching cofactor, C13. All that's left to do now is substitute, and we'll finally get the determinant value. So we've got A11 is 0 times -1, plus we've got 2 times 5, plus we've got the third element here, 1, times 4. Okay? Simplify it up, we've got 0 plus 10 plus 4. So after all this, the determinant of matrix A is 14. Yeehaw! Okay. Well, this wasn't on my class notes, but let's throw in a bonus next. In this bonus example, we're going to look at finding the determinant of matrix A, a different matrix A, new matrix A, and this time, just for variety's sake, why don't we work on row 3? So to facilitate that, how this would work then is as follows. We would have to take the answer to row 3, column 1, times its corresponding cofactor in row 3, column 1, plus the answer to row 3, column 2, times its matching cofactor, plus the answer to row 3, column 3, times its matching cofactor. Now, obviously the A values are staring us right into the face here, here, and here, but we have to do some side work to find the cofactors, which we'll do over here. We need to find the cofactor of 3, 1, which means that we will disregard row 3 and disregard column 1, and we will find the determinant of what's left, which would be -1 times 2 is -2, minus -5 times 0 is 0, so we get -2. Okay? Next, we have to find the cofactor of element C32, which would be disregard row 3, disregard column 2. Find the determinant of what's left, the little determinant, if you will. We got 2 times 2 is 4, minus 3 times 0 is 0, so we get 4. Okay, almost done. See, now the question comes up, Mr. Hansen, do we have to find all of the cofactors? No. Okay, we don't, and in fact, I have to adjust the signs here, so these aren't the final answers per se, so bear with me. But we'll keep it going. So we just have our third cofactor here, which will be C33. And we have, don't look at row 3, don't look at column 3. So we've got 2 times -5 is -10 minus 3 times -1 is -3. That will give us -10 plus 3 is -7. But keep in mind, what I actually found is the minors. To find the cofactors, you have to apply the correct signs. Remember, for row 3 here, it goes positive, negative, positive, or keep, change, keep. So we're going to keep this as this negative. We have to change this element here, change its sign, so that becomes a -4, and then we keep that one as it is, okay? So our cofactors respectively are -2, -4, and -7. Now we have everything we need to finish this off. We merely have to do substitutions, and then we'll have our determinant of matrix A, okay? The answer to the first element of row 3 is 1. So we've got 1 times its cofactor, which is -2, plus the next element here in row 3, column 2, is 4. So we've got 4 times its cofactor, which was -4. And then we've got plus, the last thing in that row was -2, times its cofactor, which was -7. So now simplifying, we've got -2 plus -16 plus 14, which is, oh, let's see here, we've got -18 plus 14, -4. So the determinant of this matrix A is -4. You can also use a graphing utility to check your work. Okay, finally, we have 3 what I call special cases where if actually you can see what's going on here, you can save yourself a lot of time. It would actually be longer to store all the elements in your graphing utility than it would be just to do the arithmetic here if you see what's going on. So in example, which is problem number 24 here, if you look at the main diagonal and circle it, so the main diagonal is this negative sloping diagonal here, you'll notice that above that diagonal you have some zeros, and those zeros form a triangle. If you can notice that you have this look, this is a square matrix that's called upper triangular because it has 0 entries above its main diagonal. So what we can do here is if you have this look, you just have to multiply the diagonal. It's as hard as that and as easy as that. So we have -3 times 11 times 2. So if you do that, you have, let's see, -33, -66. That would be the determinant of this matrix. See, it goes really fast. For the next one, you'll notice if you circle and pay attention to the main diagonal, you have all zeros below forming a triangular pattern. And again, due to the nature of computing the determinant, you would have so many things zero out, you may just take the diagonal and multiply everything together. So in this case, you'd have 5 times 6 times -2 times -1, 30 times 2, you get +60. So that's the determinant of this matrix. I really don't believe anybody could even enter the things that fast into a graphing calculator. So if you happen to see this, save yourself some time. Finally, we have what's called the diagonal case, where you have the main diagonal here, and everything other than that is zeros. So again, Same story. You're just going to multiply what's on the diagonal. So we had a -2 times a 3. I kind of covered it up. That was a -1, a 2, and a -4. You multiply everything together. Let's see. So you have these three would be +6, 12, 12 times -4, -48. That's the determinant of this big old matrix. Wow, this was what? 1, 2, 3. That was a 5 by 5. Probably wouldn't want to do that one by hand. And you can use a graphing utility, but this is even quicker if you notice it. Okay, this was a long video. I hope this helped. Thank you for watching my Hansen Math video tutorial on the determinant of square matrices. And thank you so much. And I hope everyone who watches this has a wonderful day.